These are the most frequently asked questions from section 16A1. I'm going to start with number 21 here. The absolute value of 3x plus 5 equals 5x plus 2. Now we know that we think of those absolute value bars as bars in a jail, and to escape you need two exit strategies. So the first exit strategy is a negative, and then the second one is a positive. And we go ahead and distribute the negative. And then we start moving things over. So in this case, we would go ahead and add 5x to both sides. And notice I'm skipping writing down the steps, and that's because these will get kind of long on the smartboard, and I want you to be able to see all the steps as you go through. So pretty obviously, you add 5x to both sides. 8x plus 5 equals negative 2. You should not skip those steps, but for room here, I'm going to have to do that. So I would go ahead and subtract 5 from both sides, divide by 7, and get a negative 7/8. Then with the other side of the problem over here, we're going to go ahead and subtract 3x from both sides. So 5 equals 2x plus 2. Subtract 2 from both sides and divide by 2. Now, the second part of this is we have to check our solutions. So we have to put these back into the original and see what we get. And the problem with number 21, the first part is if I put my negative 7/8 back into this equation, I'm going to get 19/8 equals negative 19/8. And that's not true. A positive and a negative are not the same. So that means even though this solution came out and I did the math right, it doesn't work. So that solution is extraneous. Then over here, if we put 3/2 back into the equation, we get 19/2 equals 19/2. That is good. That one checks out. So that is a good solution right there. Always having to check and see whether or not these work with the absolute value pieces. Then number 23. And I think what I'm going to do is give you a second to peek at this. Hit pause if you need to, and then I'm going to go ahead and erase this and start over. Again, I'll try to talk you through a couple of steps so that you can see all of this on one screen. So for 23, before I can set up my two equations, what I have to do is I have to isolate the variable, and the variable is inside that absolute value bar this time. So that 5, that negative 5 and that 3, they have to go before I can set up my two absolute value equations. So 3 times the absolute value of 4w minus 1, and there's my absolute values. I'll try to make those a little thicker so you can see them, equals 15. And then divide both sides by 3. So the absolute value of 4w minus 1 equals 5. And now you would have to go ahead and set up your two equations. So your two strategies, your two jailbreaks would be a negative and a positive. And then we go ahead and solve them. So on this first one, we would go ahead and add 1 to both sides and divide by 4, and we get a w of negative 1. And then the second one, we would add 1 to both sides and divide by 4, and then, do a little reducing there, get that down to 3/2. And then when I double checked both of these are both a go. They both end up working. Now, you should put them in and check and see for yourself that they're going to work. This one's not so bad, especially with the negative 1 here to check, but you have 4 times negative 1 up here, which would give you negative 4 minus 1 is negative 5, but the absolute value of that is 5. So that's a go. And here, 4 times 3/2 would be 6. So 6 minus 1 is 5. The absolute value of 5 is 5. And that one, the checking goes a lot faster. Then, on the next page, I have number 43. And this one, every year drives people bonkers. So let me show you this one. We cannot leave that negative out in front, so you have to divide by a negative 1. absolute value of 4 minus 8b, that looks awful, absolute value of 4 minus 8b equals negative 12. And you should stop right there and say this has no solution. You can't possibly take the absolute value of something and get a negative answer. So this one, no solutions, isn't going to happen. Number 46 is another one that gives people some trouble. So with this one, what we're going to have to do is get rid of this 1/2. And to do that, you have to multiply both sides by 2. So it'll be the absolute value of 3c plus 5 equals 12c plus 8. And then this just runs the normal course where we have to set it equal to the negative and the positive. So over on the left-hand side, distribute your negative. And then go ahead and solve. So with number 46, we'll go ahead and add 12c to both sides. And then subtract the 5 and divide by 15. So we get a negative 13/15. And then for the second one, we would subtract the 3c from both sides. And then we would subtract the 8 and divide and reduce that to a negative 1/3. And when you check these, you find out that this one does not work. Negative 13/15 does not check back into that problem. It is not going to work. But negative 1/3 does. So again, that's why we have to check our absolute value problems to see whether or not they work. Then on the next one, we've got 48. And 48 is another one that's going to take one step, really, before you can even start solving this. That 7 can't be there. So divide that 7 out of everything. And we will have 3h minus 7. And now it'll act like all our other absolute value equations, and that will have 8 minus 3h equals the negative of 3h minus 7. Distribute that negative. And go ahead and solve like normal. So we would add 3h to both sides, and we get that. And we, of course, know that that means this is not going to give us a solution over here, so this is a no. Now, that doesn't mean that the positive isn't going to work, so we still have to check the positive. And in this case, very different story. We add the 3h to both sides, and then we'd add the 7, divide by 6, and, of course, reduce that, and that comes out to 5/2. And again, if you put that back into the original, that one's going to work. So this one checks out. First part of this, you know, we said, hey, whenever we see that, an obviously false statement, that means we're not going to get a solution out of that. So that was kind of a clear-cut view of, you know, what might happen sometimes when we don't have a solution. Again, you'll need to pause this if you're still writing that down, because I'm going to go ahead and erase this and do number 51. All right, number 51, we cannot have that 1/4 in front. So what we're going to do is multiply both sides by 4. That will give us the absolute value of 4x plus 7 equals 32x plus 64. And then again, it's just a matter of having those two escape routes. So 4x plus 7 equals a negative of 32x plus 64. And 4x plus 7 equals a positive of 32x plus 64. So on the left-hand side, you distribute the negative. And then you'd add 32x to both sides. And I'm going to go ahead and do this in one step too, and you'd subtract the 7 from both sides. And really get an obnoxious looking fraction here of negative 71/36. And then on the other side, we would subtract the 4x from both sides. Subtract the 64 from both sides. And again, a very nasty fraction to work with. And I guess I'd probably just grab a calculator for this, you know, and punch it in and see whether or not it works. And it turns out that this really nasty fraction is a go. This one checks out. Negative 71 over 36 works, but negative 57 over 28, that's a no. So all that work for that solution, and it doesn't even work anyway, but that's what we have to do with absolute value. So those are frequently asked questions for section 1.6, day 1.